We're starting a new series for our own personal entertainment, maybe yours, but for sure ours, and we're calling it Unscientific Destructive Testing. So basically what that means is we are going to bake, dag, and potentially blow things up for our own personal entertainment. Typically things we made, maybe other stuff, who knows, you never know, might be a microwave and a toaster in there, I don't know. But today we're gonna start with some sections of MOLLE panel, and we've basically cut a bunch of sections of MOLLE panel, and we've got this wonderful 10,000 pound load cell that is connected to the winch on the Land Cruiser, and it's got this great little screen over here that tells us how many pounds of pull we're putting on the front of the winch. So we figured for entertainment, we'd like to see what different panels break at, or different sections of MOLLE break at. So we've got some that are laser cut and some that are bar tacked and different weights, and 1,000 denier and 500 denier and velcro, just to see what everything kind of destroys at, because you hear rumors about it, but we've never seen it. So we decided we should break it for ourselves. So we're basically starting with a piece of 500 denier Cordura, bar tacked with a type 3A webbing bar tack to it. And this is what MOLLE panels and stuff like that are made out of. Most of the MOLLE you see is either triple stitched or bar tacked, and we've got some triple stitch stuff to test. We've got some bar tack stuff to test. We've got some laser slitted stuff to test, and we're gonna find out. But we're starting with 500 denier Cordura, bar tacked to 1-inch webbing. So this is triple stitched MOLLE. It's an offshore piece. We cut a chunk out of somebody else's piece of equipment just to see what the difference is between 500 denier Cordura and bar tack webbing versus webbing triple stitched down to whatever this is made out of, probably some kind of 600-ish polyester. Well, that's 15 pounds, 20, 30. So it basically pulled stitching out of kind of everywhere, pretty much everywhere. This is sheet Velcro, so big sheets of Velcro sewn down to 500 denier Cordura. So technically we didn't get to test this one because it tore as we were assembling it. So the slitted Velcro, laser slit Velcro attached to 500, the Velcro let go. It basically almost zero. No, it was probably 5 or 6 pounds. So this time we're going to test 500 denier Cordura sewn down to 1,000 denier Cordura and see where it breaks and see if we may need to test something else. But I'm betting we're going to get a number out of this one. Oh, 60 pounds. And she stops. 60 pounds, way better than I expected. Who knew? Let's look at, broke about the same as the 1000 denier Cordura did. Broke right in here, in between the tabs. So again, maybe you could stitch that down and make it a little stronger, but the reality is 60 pounds is way better than I had expected. Okay, so if we go in order of load, it went like this. So this one held the most. These two were fairly similar. The Cordura I think was a touch higher. 500 was at like 60-ish pounds, and then this was about 5 pounds. Oh, for entertainment, I thought we would pull the actual straps we've been using to hook them up, which are just a couple bar tacks and a piece of 1-inch webbing, just to see what the difference is when you bar tack a piece of webbing to a piece of webbing versus to a piece of Cordura or something else. Watch that thing. Let's see what that thing says. What's it at? Six-ish, probably. Yeah, it was about 7 or 8. So that's it. So the interesting thing about this is this piece did not break at the bar tack. It actually broke in the middle of the webbing at about 700 pounds. So next time on Unscientific Destructive Testing, we are going to take a bag and we're going to load it with, I don't know how much weight, but some weight, 30, 40, 10, 15, 20 pounds, I don't know, 100, whatever. And we're going to hook it behind the cruiser and we're going to drag it down a gravel road until it starts to leak. And then we're going to bring it back and we're going to hook it up to the load cell and we're going to pull it in half. So we're going to find out how far it drags and then how much weight it is to actually pull it in half. That's going to be the next bit of entertainment.